Alright, let's go over adding and subtracting rational expressions, part 2. This one is going to be a little bit more difficult because we have binomials in the denominator. So still we want to rewrite this with common denominators so we can add them, because to add fractions we need to have common denominators. So if we look at this, we have n minus 6 and n minus 1. What is the common denominator for this? Well, let's take a step back and look at adding fractions. So let's say we have 2/3 plus 1/2. What's the least common multiple of 3 and 2? Well, it's 6. And the way we got that is we simply just multiply these together. 3 times 2 is 6. So then this is multiplied by 2, multiply this by 2, we get 4, multiply by 3, multiply this by 3, we get 3, and then we can add them together, we get 7/6. So we're going to do the same thing here. We're just going to multiply these together. So multiply this by n minus 1, and of course it's the entire thing, n minus 6 times n minus 1. Multiply this by n minus 1, and now here multiply by n minus 6, and by n minus 6. Alright, so let's not multiply this together, so just rewrite it. N minus 1, n minus 6, n minus 1, n minus 6. Okay, now we do have to multiply this though, so we can add them together. So distribute the 6, get 6n minus 6. And this is going to be 3n minus 18. Okay, now let's add these together. 6n plus 3n is 9n. Negative 6 plus negative 18 is negative 24. So now the reason why I didn't multiply these together is because if we could reduce, it's going to be a lot easier to do so if it's already factored. So let's see, does anything go into both of these? Well, 3 does. So this would be 3 times 3n minus 8 over n minus 1, n minus 6. Nothing cancels out though, so now let's rewrite it as the way it was, 9n minus 24. And we can multiply these together. N times n is n squared. N times negative 6, negative 6n. Negative n plus 6. And finally we get 9n minus 24 over n squared minus 7n plus 6. And of course, this is also an acceptable answer. Let's look at a more difficult one. 3 over n minus 4 plus 2n minus 8 over n squared minus n plus 12. So we can do the same thing we did before and just multiply these together to get our common denominator. And that would be perfectly acceptable. But this is going to be a little bit complicated because we have a trinomial here, and then we have a binomial, so we multiply these, they're going to get into be pretty big expressions. We'll still get the correct answer, do everything correctly, but it could be a little difficult. What we should do here is look at the factors of these denominators. So n minus 4 is really just n minus 4. But n squared minus n plus 12 could be factored. It's a quadratic, so we can do n and n. They're any numbers that add up to negative 1 and multiply to 12. So that's going to be So let's look at an even more difficult one. 3 over n minus 4 plus 2n minus 8 over n squared minus n minus 12. So we can do what we did before. Multiply this by n squared minus n minus 12, n squared minus n minus 12. Multiply this by n minus 4, multiply this by n minus 4, and we'll have common denominators. But this is going to be a little confusing because we have a trinomial and a binomial, and we can still get the correct answer. It's just going to be a lot of work. So let's look at a different option. So let's get rid of this. And instead, let's examine these denominators. We have n minus 4 and n squared minus n minus 12. This quadratic expression looks like it could be factored, so let's factor it. This is n and n. We need numbers that multiply to be negative 12, but add up to negative 1. That's going to be negative 4 and positive 3. So this is really n minus 4 times n plus 3. This one's already n minus 4, so if we multiply this by n plus 3, we'll have the same exact denominators. So just multiply this term by n plus 3, and by n plus 3, and we'll have the same thing because this is really n minus 4 times n plus 3. So now we'll have common denominators. So now looking at this, this didn't change. This is exactly the same thing, so this numerator is going to remain the same. We didn't make any changes, just wrote it differently. But in this expression, we multiplied by n plus 3 in the denominator and in the numerator. So we have to multiply this out. We'll get 3n, 3 times n is 3n, then 3 times 3 is 9. So now that we have like terms, we could add the common denominators, we could add these together. So 3n plus 9 plus 2n minus 8, combine like terms, 3n plus 2n is 5n. 9 plus negative 8 is positive 1 over n minus 4 times n plus 3. This can't be factored and reduced, so this is the answer.